Imagine a traveler from another star system diving through our neighborhood right now. That traveler is 3I Atlas, short for the third interstellar visitor discovered by the Atlas survey. Over the next few weeks, we are entering the most exciting part of its journey. This object follows a hyperbolic path, which means it is not bound to the Sunday. It will swing in, show us what it is made of, and then head back into interstellar space. There is no return loop and no threat to Earth. It will remain hundreds of millions of miles away the whole time. Here is the timing that matters. 3I Atlas is expected to reach its closest point to the Sun, its perihelion, around October 29 to October 30, 2025. It will be just inside the orbit of Mars at roughly 1.4 astronomical units, which is about 130 million miles, or around 210 million kilometers. That is when solar heating should push its activity to a peak and when telescopes will race to capture data. Before that, there is a special viewing chance from the Mars neighborhood around October 3rd. In planetary terms, close still means on the order of tens of millions of miles, but spacecraft at Mars can try to grab a side-on look that we cannot easily get from Earth. After perihelion, another vantage point comes into play: the Jupiter system. The JUICE spacecraft has a window in early to late November to watch 3I Atlas shortly after its solar close pass, when the coma and tail could be at their brightest and most extended. Coordinating multiple spacecraft around different planets for the same interstellar object is rare, and that makes this month extraordinary. What are we seeing so far? As 3I Atlas warms, it sheds dust and gas like a typical comet. Recent images show a growing tail and an expanding coma, classic signs of increasing activity as it approaches the Sunday. There is also a color story that has astronomers buzzing. A greenish tint has been reported around the comet. Green Comet are often linked to dicarbon, the molecule C2, which glows under sunlight. But early spectra have thrown a curveball, with hints that some of the usual carbon-bearing molecules might be less abundant than expected. That opens the door to possibilities like freshly exposed material behaving differently, or other molecules, such as cyanide, contributing to the glow. Better spectra in October and November should clarify which molecules are responsible for the color. How big is the solid core, the nucleus? That is always a tough question for a dusty, active comet, because the glowing coma hides the center. Current analyses bracket a wide range from a few hundred meters up to several kilometers across, with a rough upper bound of a few miles. That sounds large, but in comet terms it is still modest, more like a mountain than a continent. You may also have seen bold headlines suggesting the comet could be extraordinarily massive, on the order of tens of billions of tons. That idea comes from the observation that gas jet rocket effects have not noticeably nudged its orbit, which would imply a heavy nucleus. It is a clever inference, but not a settled measurement. It depends on assumptions about how much gas and dust are venting, and in which directions. Treat it as a working hypothesis that will be tested with new observations near Mars, around perihelion, and from the Jupiter neighborhood afterward. Why do interstellar comets matter? We have only seen two before this one. In 2017, we found Oumuamua, which looked asteroid-like and behaved oddly. In 2019, we found Borisov, a more classic dusty comet. 3I Atlas gives us a third data point in a very small sample, and every detail helps us understand how other planetary systems build and then eject small bodies. From its discovery in mid-2025, its path clearly indicated an unbound trajectory with a high excess speed that will not loop back to the Sunday. It will also keep a safe distance from Earth, with the closest Earth distance still in the hundreds of millions of miles in December. Chemistry is where surprises may hide. If 3I Atlas turns out to be rich in carbon dioxide and other volatile ices, that would point to formation in the cold outer zones of its home system, beyond the snow lines where such ices can condense. Its shifting color and evolving tail will help pin down which molecules are being released as the surface heats, cracks, and exposes fresh ices. The best clues will come from comparing visible light and infrared observations, especially during the October and November peak. Space weather will matter too. If a coronal mass ejection, essentially a gust of charged particles from the sun, sweeps past the comet, we could see the tail brighten, kink, or ripple. That kind of interaction teaches us how dust grains are lifted, how jets form, and how the coma breathes under changing solar wind conditions. Because this comet is inbound fast and not bound at all, it samples a slightly different speed and environment than the long-period comets we usually study, turning it into a natural laboratory for testing our models. There is even a big-picture idea gaining attention. Interstellar objects like 3I Atlas might act as seeds inside young star systems, helping to kickstart planet formation. In some simulations, more massive stars are better at capturing passing interstellar bodies. Those captured chunks could give dusty disks the head start they need to grow giant planets more efficiently. It is still a hypothesis, but having a well-characterized interstellar comet in hand makes it testable with real numbers instead of just theory. If you are wondering whether to worry, the answer is no. The trajectory solutions show 3I Atlas never comes remotely close to Earth. At perihelion, it is still about 1.4 astronomical units from the Sun, just inside the orbit of Mars, and its nearest distance to Earth is even farther than that. Media images of big, dramatic tails can be misleading. A tail can stretch for millions of miles and still be incredibly tenuous. Think of it as a ghostly, glowing cloud of ultrafine dust and gas, not a solid object barreling toward us. So what should you picture as this story unfolds? Imagine a dark, irregular chunk of ancient ice and rock, black as charcoal, until sunlight stirs it, jets flicker on, the coma billows. A tail unfurls away from the Sunday. In late October, activity ramps up just as Mars-based spacecraft try for a side-on look. Weeks later, the JUICE mission peers across the inner solar system to watch the aftermath. If the green tint strengthens, spectrographs will dissect it to confirm which molecules are glowing and in what amounts. If the tail kinks or ripples, that is the solar wind talking. If the nucleus seems steadier than expected, the heavy nucleus idea gains support. If subtle accelerations show up, those mass estimates will drop. Either way, we learn. What makes 3I Atlas special is the mix of rarity and timing. We have caught an interstellar visitor early enough to organize a global and even interplanetary observing plan. We have modern tools, from Hubble to giant ground-based telescopes, already lined up, plus multiple spacecraft with unique vantage points. By the time it fades back into the dark, we should know far more about its size, composition, and behavior than we ever learned from Oumuamua, adding a crucial new chapter to the tiny but growing book of interstellar objects. That is why this month matters. It is not just a pretty tale, it is a once-in-a-generation look at someone else's leftovers from planet building, tossed into the void long ago and now, briefly crossing our stage. For your 10-minute voiceover, keep a natural pace and let the calendar anchor the narrative. October 3rd for the Mars viewing opportunity, October 29 to October 30 for the perihelion fireworks, and early to late November for the JUICE follow-up. Close with the reminder that it stays far away, it leaves again, and it leaves us smarter than we were.